Here we're going to use what's called the remainder theorem to evaluate a function. So notice how we use synthetic division a lot. We know if we get no remainder, that means it's a 0, but it actually works for other values. If I want to know what would I get if I plug 2 into this equation, and I could just plug 2 in, right, and do it by hand, but you notice, especially if I'm plugging in a bigger number, 2 to the third or something to the third could end up getting kind of big kind of quick, and so synthetic division is really fast. So sometimes doing synthetic division can be quicker, and what it says is whatever we end up with as the remainder is the same as what we would have got if we just put 2 into the function. Alright, and then also don't forget, if you have any missing terms, you have to put a 0. So this is 2x to the third, negative 3x squared, no x's, and negative 8's the constant. So add multiply, so add multiply by 2, add multiply by 2, add multiply by 2, negative 8 and 4 gives me negative 4. So that's another way, or a shortcut kind of way, to figuring out what I would get if I just put 2 directly into the function. And then here they also want me to write down the quotient and the remainder. So the remainder was negative 4. The quotient is, if this was on x to the third, this is on x squared. So 2x squared plus 1x plus 2. And the only reason they're asking for the quotient and the remainder is to make sure that you use division to find this instead of just plugging it in directly. But the pattern would be, if you're trying to use it to plug in, you don't need the rest of that stuff. You're just saying, if I do synthetic division with 2, it's the same as plugging 2 into the function.